Swayam Prabha. Digital India. Educated India.
So, last class I was discussing that how we can use the plate load test data to determine the settlement or allowable bearing capacity of real foundation. Now, I was discussing about that how we can use the plate load test data for two different plate sizes, and then we can determine the dimension of the foundation. So, this is the problem. So, where a smaller plate of size 30 centimeter, 30 centimeter cross 30 centimeter, giving 25 millimeter settlement under 25 kilonewton load, and the larger size plate of 60 centimeter cross 30 centimeter giving 25 millimeter settlement under 75 kilonewton load. So, what would be the dimension of a square plate, a square foundation to get 25 millimeter settlement under 1000 kilonewton load? Okay, so, now for this particular case, we have to express this total load in this way, that is the A1 m plus P1 n, where m and n are the two constants, and the AI is the area of plate and Pi is the perimeter of the plate. Okay. So, now for this particular case, there will be a Q2 second plate also, that is will be A2 m P2 n. Okay, so, now it is A1 is the area of the first plate. So, that will be 0.3 square. So, this will be 0.09 meter square, and the perimeter A2 for the perimeter P1 for the first plate will be 4 into 0.3. So, this is 1.2 meter, that is the perimeter of this square plate. Now, A2 is the area of the second plate 0.6 square, that is 0.36 meter square. So, the perimeter of the plate 2 will be 4 into 0.6, that is 2.4 meter. Okay. So, I can write two equations. So, the first case our applied load is 25 kilonewton, that is Q1. So, A1 is 0.09 m plus 1.2 n. So, this is equation 1, and in the second equation it is 75, that is 0.36 m plus 2.4 n. So, this is second equation. Okay. Now, if I solve these two equations, after solving these two equations, we will get, after solving, we will get m is equal to 139 and n is equal to 10.41. Okay, suppose you have a data of say 3 plate load test, then also you will get the 3 equation. Okay, equation 1, 2 and the third one 3, but your unknown is 2, it is m and n. So, in such case you have to take the two equations separately. For example, you solve equation 1 and 2, then you will get one m and p m and n values. Then you solve equation number 1 and 3, then you will get another m and n value. Then you solve equation 2 and 3, then you will get another m and n value. So, that means you will get 3 m value, 3 n value in that case. So, you take the average of that m and n, and that m n average will be your actual m n value. Okay. But here the two plate load test data are given. So, that is why we are using only two equation and two unknowns. So, one set of value we are getting, and that is 139 and 10.41. So, the general equation, the q will be equal to q will be equal to 139 a plus 10.41 p. Okay. So, it is a square plate. Now, this general equation we have to use for the square footing, whose dimension we want to determine. So, that dimension it is a square, we say it will be the b cross b. So, we can write that this equation I can write that q f is equal to 139 a f plus 10.41 p f. So, the q f is 1000 kilonewton, because we have to use the same settlement. So, same settlement corresponding to same settlement you have to compare all the cases. So, that means settlement is same, q is 1000 kilonewton. So, this will be 139 and your area of the foundation is b square plus 10.41 into 4 b. Okay? Because remember that, so why we are comparing this 1000 directly, because we have taken the same settlement. So, we have to compare it for the same settlement value, footing and the plate. So, now this will be finally we can write that 1000 is equal to 139 b square plus 41.6 b, or I can write 139 b square plus 41.6 b minus 1000 is equal to 0. And after solving these equation, we will get a b value which is equal to 2.54 meter. So, the dimension of the foundation will be 2.54 meter cross 2.54 meter. So, this will be the dimension of the plate or foundation, whose 2.54 cross 2.54. So, this is the minimum dimension is required for this particular foundation to get 25 millimeter settlement under 1000 kilonewton load. Okay. So, now this way also you can determine the dimension of the foundation by using plate load test data. So, next one that I will discuss that how you will use the SPT value or standard penetration value to determine the bearing capacity, and then finally determine the dimension of the foundation. So, the Teng 1962 proposed empirical equation by which we can determine the net ultimate bearing capacity for strip footing and the square and circular footing by using these two equations. Okay. So, the first equation is for strip footing and the second equation is for square and the circular footing. So, these are empirical equations where df is the depth of foundation and Rw and Rw dash, these are the correction factor due to water table. Okay. So, that I will discuss how you will determine the Rw dash and Rw. N is the corrected N value, okay, for overburden pressure. So, this is the corrected N value and this is the average N value. So, what is average N value, that I will also discuss. and if the depth of foundation is greater than B, you consider depth of foundation is equal to B. Okay. So, and this is the two equations. Now, how I will calculate the R w and R w dash? So, what is R w dash and R w? So, by using this chart, we can determine the R w dash and R w. So, here suppose we have the foundation. This is the base of foundation, this is the ground level. So, now this is two cases. The first case where water table position is here, say. Okay. So, that means this distance, the position of the water table from the surface is called dw, and in the second case, this is ground surface and this is the position of the water table, which is below the base of the foundation. So, first case 1, water table is above the base of foundation, in case 2 which is below the depth of foundation. So, this is the water table position. Now, here this is dw dash. So, your first case dw is a certain value and dw dash will be equal to 0. Okay. So, dw dash will be 0, and for your second case dw dash has a certain value, but the dw is water table is not present. So, this value or this correction factor will be this correction factor R w will be equal to 1, because in this case you can consider that dw is equal to df, because dw is equal to df, because water table your df, that means water table has the depth of the foundation. So, in first case we can consider dw has certain value, and in that case dw dash which will be 0. That means, here you can consider dw dash at the base of the foundation. So, that means, because water table is above the base of the foundation. So, in the first case dw is certain value, dw dash is equal to 0. In second case dw is equal to df, depth of foundation, and dw dash has some certain value. Okay. So, or you can consider in second case R w is equal to 1. So, now here dw by df and dw dash by b is given. So, the R w is corresponding to dw by df and R w dash is corresponding to dw dash by b. So, this way we can calculate the correction factor R and R w dash. So, these two value will determine based on the position of the your water table. So, you can see in the second case always the R w is equal to 1, because if I consider dw is equal to df. So, this value will be 1. So, 1 corresponding to correction factor is 1. And because here water table is below the base of the foundation, and so in your first case that dw or R w dash is always 0.5, because it is above the base of the foundation. So, R w dash you can say, if I consider dw dash equal to 0. So, this is 0, this is 0.5. So, 0 corresponding to correction factor is 0.5, this is 1 corresponding to correction factor is 1. So, that means, in the first case R w dash is 0.5 and R w we have to determine, and second case R w is 1 and R w dash we have to determine. Now, the next one, that this bearing capacity equation or this SPT value, Here it is, we are getting the net ultimate bearing capacity, that means it is in terms of bearing capacity only. Now, correlations are also given, the empirical correlations are also given considering the settlement as well as the bearing consideration. That means, your settlement is within the permissible limit and there is an adequate factor of safety where the with respect to the your shear failure. So, considering that settlement effect also, because initial correlation is given considering the bearing, but if I consider both the consideration, then that will be the allowable bearing capacity. So, that allowable bearing capacity also can be determined based on the SPT value. So, if you know the SPT value, so if I use these two correlations, so this is proposed by Peck, Hansen and Thorburn 1974. So, this is the first correlation which is suitable for isolated foundation and second correlation is suitable for wrap foundation, and remember that these correlations are valid if your n is within 5 to 50. Okay. And this is the empirical correlation. So, unit is very important, you can see the unit is ton per meter square, but your settlement is in millimeter. Okay, remember that. And you have to apply again water table corrections, where remember that the dW is depth of water table below ground surface. Here it is not the base of the foundation, it is below ground surface. Okay. And then this n is the your corrected SPT value, and this is the net allowable bearing capacity of the foundation we can determine. Similarly, Meharov also given some correlations by which we can use. So, these we can use and determine the net allowable bearing capacity. So, this is the correlations which is given in terms of ton per meter square and in terms of kilonewton per meter square also. So, again it is settlement is in millimeter. So, this R d is the depth correction factor for 2 R d 1 and R d 2 are given. So, R d 1 is applicable if your width of foundation is less than equal to 1.2 meter, and if the width of foundation is greater than 1.2 meter, then what will be the R d 2. So, these two corrections we will get. So, depth corrections are given and then permissible settlement and width of the foundation. So, this correlation we can use, then 10 correlations also we can use. So, these correlations also here R w dash is given, R w dash is the water table corrections and n is the corrected SPT value, that field n into the correction factor which we have to apply, but here most of the cases the corrected n value are given in the problems. So, this is the S is the permissible settlement which is in millimeter, C d is the depth correction factor, and this R d is the R w is the water correction factor. So, now how you will calculate the C d? C d you will calculate by using these equation, and C n correction is given. Suppose if your uncorrected or direct measure n value is given, then how we can correct the C value. So, that C n correction. So, this is n field means the measure n value, and the C n is the correction factor. So, that correction factor you can determine by using these correlations. Okay. So, and this P 0 by is the effective overburden pressure, and again these are empirical relationship. Remember that this unit is very important. So, this stress in kg per centimeter square. Okay. So, if P 0 is within this limit, then you use this expression, and if it within this limit, then you use this expression to determine the C n. And another case, if the corrected SPT value directly given, then you can use them directly. If the measure is given, then you have to apply the correction factor C n, and correction factor you can apply by using these equations. So, this is correction factor basically by overburden pressure. As I mentioned during my SPT discussion, that in some cases the corrections are done by using only the overburden, some cases the corrections are done by using all other corrections correction factors, because correlations are given by only corrected by overburden pressure or by corrected by using all the corrections factor, but this case this correction is based on overburden pressure. So, an RW dash is the depth of water table from the base of the foundation. So, here this is RW dash. So, remember that different way these water table corrections are incorporated. Most of the cases is the two types. One way is water table is considered from the base of the foundation, another way water table is considered from the surface of the foot or ground surface of the soil or the ground surface. Okay. So, you remember that which or you have to use the proper correction factor which is recommended by the different theories. So, here the DWF, DW dash which is depth of water table from the base of the footing. So, now when you are talking about the permissible values of settlement, then here as per the IS code, for different foundation on different types of soil, this permissible settlement values are given. So, this is the chart for the permissible settlement value, that is for isolated footing, whether it is steel structure or RCC structure, the permissible settlement on sand or hard clay is 50 millimeter, and for wrap foundation this is 75 millimeter. Whereas, for plastic clay, this is for isolated footing, it is steel structure is 50 millimeter and RCC structure is 75 millimeter, and for steel structure and RCC structure for raft foundation on plastic clay is 100 millimeter. Similarly, you have to check the differential settlement and angular distortion also, and those limits are also given. So, as I mentioned, in most of the cases in our design problems that we will solve, I will discuss the maximum settlement only, and we will assume there is permissible settlement is within the or the differential settlement is within the permissible limit, or angular distortion is also within the permissible limit. So, as I mentioned, so there is a three types of displacement checks we have to do, as in the on my previous lecture also I have discussed, that is the maximum settlement, differential settlement and the distortion, and the difference between the differential settlement and angular distortion. In differential settlement, suppose two particular footing will deform in by different amount, and in the angular distortion the total structure will deform in such a way that it will tilt. Okay. So, that these things we have to also check, but here if your soil type is different for your different foundation, or the loading is loading amount on different foundation is significantly different, then we have to also check the differential settlement and the angular distortion. But in this case, we will assume that all the problems, the soil parameters are more or less same, or there is not significant difference of the loading amount and the soil parameters. So, we will check only the maximum settlement. But remember that not only the maximum settlement check is sufficient, but most of the case this is the major check. But if the soil parameter is different or the loading amount is different on different columns or foundation, then you have to check the other two settlement, that is the differential settlement and the angular distortion. So, now we have the second another example problem. So, that example problem is based on the SPT value that I have already discussed. So, determine the net allowable bearing capacity or pressure of a square footing of size 2 meter cross 2 meter resting on sand with the following properties. So, that means how much allowable bearing capacity we can pressure we can apply on a foundation of 2 cross 2 meter square resting on the sand whose SPT values are given. Okay. So, water table is located at the depth of 2 meter from the ground surface, the depth of foundation is 1.5 meter, the permissible settlement is 50 millimeter and factor of safety against bearing is 2.5. Okay. So, that means in this problem we have to determine the allowable bearing capacity. So, you have to consider the bearing capacity as well as the settlement. Both the cases you have to consider. So, we will get the allowable bearing capacity. And in few, so that means we have to use the correlations that I have discussed. In few correlations it is only bearing capacity will give, and few correlations will give directly the allowable bearing capacity, where we can where the settlement and the bearing both the things are considered. So, now we will discuss or we will consider one by one this all the bearing capacity equations or the correlation those are used. So, that means, this is the chart or the SPT versus depth. So, this is my corrected SPT value. Okay. So, this is the n value and this is the depth or z. Z is the elevation or the depth from 0 to 10 meter. Here the SPT values is given 0.75 meter interval. This is 1.5 SPT value is 17 and to 9 SPT value is 40. So, and this chart is or this n versus depth plot is here. So, this is the variation of the SPT value with depth. Now, we have to determine the allowable bearing capacity for this particular footing dimension. And one way also we can we have the if we have the allowable bearing capacity, then we can determine the dimension of the foundation. Okay. But this allowable bearing capacity is determined under different dimension of the footing. So, that dimension is given 2 cross 2 meter. Okay. So, now we have to determine what will be the allowable bearing capacity of the foundation. Now, here suppose we have that foundation okay, whose depth is 1.5 meter. Water table position is 2 meter from the ground surface, that means from the base of the foundation is 0.5 meter. Okay. So, our dw dash is 0.5 meter, dw dash is the depth of the water table from the base of the foundation and df is 1.5 meter and width of the foundation b is 2 meter. Okay. So, first correlations that we will use is the Teng correlations. Okay. So, first correlation, that is my case 1, that we will consider the Teng correlations. (1962). And this is for square footing. So, as per the Teng correlation, net ultimate bearing capacity. So, this is the net ultimate bearing capacity is 1/3 n square b r w dash plus 300 plus n square into d f r w. Okay. So, this is the correlations that we have to use. So, this n value we have to determine. So, as I mentioned during the Teng correlation, this n is the average n value. So, how we will determine the average n value and how we will determine the r w dash and r w, that I will discuss in the next class. And then I will also discuss the other correlations where we can directly calculate the allowable bearing capacity. Here we are getting the net ultimate bearing capacity, only bearing capacity. So, bearing capacity means you have to apply the factor of safety, and allowable bearing capacity it is in terms of permissible settlement. So, factor of safety is not required. So, those things I will discuss in the next class.